Hello students, in this lecture we are going to solve the second numerical from our exercise of the solution, second chapter, that is solution. Uh, the second numerical is the vapor pressure of water at 20 degrees Celsius is 17 mm of Hg. Actually at 20 degrees Celsius water has vapor pressure of 17 mm of Hg, and it is the vapor pressure in a pure form of the water. And we know in pure form vapor pressure can be denoted by P01. That's why this will be the value for P01 of water is equal to 17 mm of Hg at 20 degree Celsius. That means here temperature is 20 degree Celsius. Okay. Then what is the vapor pressure of the solution containing 2.8 gram of urea in 50 gram of water? It means there is a solution of urea which is made by dissolving 2.8 gram urea in a 50 gram of water, and if there is a solution of urea, that means here solvent will be water, because solution is made in a water, and solute will be urea. Solute will be urea, and the mass of the urea, that is a solute, which is represented as W2, is equal to 2.8 gram. This will be the mass for the urea. And water, the mass of water, that is the mass of solvent, which is represented by the letter 1, W1, and that's why it will be 50 gram. Here in both the cases, the molar mass of the water, which is represented by M1, that is 18 gram per mole. We know there is no given value in the problem, but it should know, because uh, we studied in 11th standard that how to calculate the molar mass of the substance, and water having molecular formula H2O, that's why molar mass 18. Molar mass of the urea, which is represented by M2, urea having molecular formula N2H4CO, and that's why it carry molar mass 60 gram per mole. Okay, these are the given values for mass and molar mass, as well as there is a vapor pressure of pure water, that is 17 mm of Hg, and we have to calculate the vapor pressure of the solution, that is P. We are going to calculate the vapor pressure of the solution, that is P. Here I have one formula, that is delta P upon P01, which is called as relative lowering of vapor pressure. We studied in a theory uh, ratio of lowering of vapor pressure to the vapor pressure of a pure solvent in a pure solvent, that is called as lowering of vapor pressure, which is equal to x2. But we know that x2 is nothing but n2 upon n1 plus n2, where we take n2 as a negligible value, and if n2 is a negligible value, in that case this formula will become n2 upon n1, and if x2 is equal to n2 upon n1, which is equal to n2 means the number of moles of solute, which is represented as W2 upon M2. N1 is the number of moles of solvent, which is represented as W1 upon M1, because number of moles is equal to given mass upon molar mass. Here also number of moles of solvent is equal to given mass of solvent upon molar mass of solvent. Okay, and that's why this formula will become delta P upon P01 is equal to W2 upon M2, and this term m1 goes to numerator and w1 goes to denominator, and that's why this formula look like this. Now delta p is equal to can be written as p01 into w2 upon m2 into m1 upon w1. Okay, now we can put the values. Delta P is equal to P01 having 17 value multiply by W2 having 2.8 then m1 having 18 value upon m2 having 60 value and w1 having 50 value. And we can calculate the term like this: 17 multiplied by 2.8 as it is, 18 as it is, 60 into 50, it will become 3000, and 3000 can be written as 17 into 2.8 into 18 divided by 3 into 10 raised to 3. 3 18 divided by 3 means it will give 6, and that's why the value becomes 17 multiplied by 2.8 into 6 into 10 to the power minus 3. On multiplication of these three terms, we will get the value of delta P. For the multiplication of these three terms, we should go for the log calculation. So go for the log calculation, that is log of 17, log of 2.8 and log of 6. Here characteristic of 17 is 1, characteristic of 2.8 is 0, and for 6 also 0. Then go for the log calculation. Take your log table. In log table, go for the logarithm table. In logarithm table, log of 17 is 2304. 2304. And log of 28 having value 4472. 4472. And the log of 60 having value 7782. 7782. All the terms are in a multiplication, that's why there should be addition. 8, 15, 15, 14, and here there will be 2. Go for the anti-log of this value. Go for anti-logarithm table. In anti-logarithm table, we are going to calculate the anti-log of 0.45. 0.45 in a 5. 0.45 in a 5. 0.45 in a 5 is 2851, and mean difference is 8 having 5, that's why 2856. The value will be 2856 into 10 to the power 2 into 10 to the power 2 means 2.856 into 10 to the power 2 into 10 to the power minus 3. Now the term will become 10 raised to minus 2 will get cancelled, here minus 3 will get cancelled, and that's why it will remain only 10 raised to minus 1. When we apply 10 raised to minus 1, the term will 0.2856, and this is the pressure, that's why it is taken in a mm of Hg. This is the value for delta P. But here we are going to calculate the value for P, but we know the formula for delta P is equal to P01 minus P, and that is nothing but lowering of vapor pressure. As per the definition, it is the difference between vapor pressure of a pure solvent and vapor pressure of a solution. That's why delta P is equal to P01 minus P. Here delta P having value 0.2856, which is equal to P01. P01 value having 17 mm of Hg minus P. When this P comes to left hand side, equation will be written as P is equal to 17 minus 0.2856, and when we calculate the term P is equal to, here we can subtract 0.2856 from 17, and when we subtract 0.2856 from the 17, we will get the value 4, 4, here 1, here 7, and here 16, here 16, and that's why the answer will be 16.71 mm of Hg. In your textbook, The value is given, answer is given like this, 16.17. So correct it. Actual the answer will be 16.71. We can repeat once again how to solve this problem. First of all, we take given data. There is a solution of urea in water. That's why water is a solvent, urea is a solute. The vapor pressure of a pure water at 20 degrees Celsius is given. That's why P01 value is 17 mm of Hg. The mass of urea is 2.8, which is dissolved in 50 gram. That's why mass of urea can be represented by W2 and mass of water is represented by W1, having value 2.8 and 50 respectively. Molar mass is also taken. M2, that is the molar mass of the urea, which is 60 from its molecular formula, and the molar mass of water, which is 18 from its molecular formula. Now we use one formula, delta P upon P01, that is a relative lowering of vapor pressure, which is equal to X2. But X2 is equal to N2 upon N1 plus N2. But here N2 having negligible value, that's why N1 plus N2 becomes N1. And so that N1 upon N2. But N1 and N2 are the number of moles of solvent and solute. And number of moles can be written as given mass upon molar mass, given mass upon molar mass. That's why M2 is equal to W2 upon M2 and N1 is equal to W1 upon M1. And that's why the formula becomes delta P upon P01 is equal to W2 upon M2 into W1 upon, M1 upon W1, and delta P is equal to P01, while P01 on the right hand side, it will become delta P is equal to P01 into W2 upon M2 into M1 upon W1. By putting the values 17 into 2.8 into 18, 60 into 50, we get the final calculation at 0.2856 mm of Hg using logarithm. But delta P is equal to P01 minus P according to the definition of lowering of vapor pressure. Delta P is equal to P01 minus P, and that's why the value becomes 0.2856 is equal to 17 minus P. But when P is on the left hand side, it will become P is equal to 17 minus 0.2856, and we will get the final answer, that is 16.71 mm of Hg. And in this way we can solve this problem. Okay. This is about the second problem. Now I think we should go towards the third problem also. Third problem also is very simple. You can solve easily. To solve this third problem, I would like to read the problem first. The third problem is a 5% aqueous solution of cane sugar has freezing point 271 Kelvin. Calculate the freezing point of 5% aqueous glucose solution. Means here there are two types of solutions are given. The first solution is of cane sugar and second solution is of that is glucose. That means for first solution we can take solvent as a water. Aqueous solution means solution is in a water, and solute is cane sugar. Cane sugar means sucrose. And for this solution certain values are given. 5% aqueous solution, 5% means total amount of solution, out of which 5 gram is the mass of the cane sugar, and that's why 5% indicates that is the mass of the cane sugar, that is solute, which is represented by W2, and that's why W2 is equal to 5 gram. As well as here there is molar mass of the cane sugar, that is M2 is given, that is 342 gram per mole. These are the two values are already given. Then has freezing point. This solution having freezing point of the solution can be represented by TF, which is equal to 271 Kelvin. The freezing point of the solution is 271 Kelvin. And now calculate the freezing point of the second solution having 5% aqueous glucose. Go for the second solution. For second solution, here solvent is water, same, and solute, that is glucose. For this solution is 5%. That's why again W2 is equal to 5 gram. Here you can write W2 or you can write W cane sugar, that is Cg, and molar mass of the cane sugar, that is Cg. Here also you can represent it as molar mass of the glucose is 5 gram. Given mass of the glucose is 5 gram and molar mass of the glucose is 180 gram per mole. Here molar mass of the glucose is not given, but you can calculate from its formula, because glucose having formula C6H12O6, and from that molecular formula the molar mass will be 180 gram per mole. These are the given values, and from these values we are going to calculate the freezing point of the second solution, that is TF is equal to what. Now in this case what we have to do, we have to calculate the freezing point of the second solution, and to calculate the freezing point of the second solution we will use one relation, that is delta TF is equal to T0F minus TF. But here we don't have the value of T0F and we don't have the value of TF also. Then how to calculate the value of T0F? T0F is the freezing point of the pure solvent, and here solvent is water in both the cases, and that's why the T0F value will be the freezing point of the water, and freezing point of the water is 0 degree Celsius, and 0 degree, that means 273 Kelvin. 0 degree means 273 Kelvin. Here also T0F value will be 273 Kelvin. But to calculate the TF, we should know about the delta TF. And to calculate the delta TF, we again use another formula, that is delta TF is equal to KF into M. KF into M. Where KF is the molal, KF is called as the molal depression constant, and M is called as the molarity. And for molarity we can use the formula like W2 upon M2 into W1 in kilogram, and to represent that kilogram we put 10 raised to 3 like this. Okay, and that's why the formula of delta TF becomes KF into W2 upon M2 into W1 into 10 raised to 3. Then we will go for the first solution first. We will put the equation for the first solution, and for the first solution equation will be delta TF, that will be for Cg, that is cane sugar, is equal to KF into W2, that is WCG upon MCG into W1 into 10 to the power 3 into 10 to the power 3. That will be the first equation for the first solution. For second solution, equation will be delta TF, that is for the glucose G, is equal to KF into W2, here glucose, and M2, that is Mg, molar mass of the glucose, and W1 into 10 raised to 3 as it is. That will be the equation for the second solution. Now we can take 1 by 2 to solve the values. We can take 1 by 2. In 1 by 2 solution, what will happen? Delta TF Cg upon delta TF G is equal to KF into Wg upon Mg W1 into 10 to the power 3 divided by KF into WCG MCG, here Wg upon Mg into W1 into 10 to the power 3. Here the common term will be cancelled. 10 raised to 3, 10 raised to 3 will be cancelled. W1 will be cancelled. Kf will be cancelled. Okay, and that's why equation will become delta T of Cg, means delta T of Cg can be represented as T0f minus T0f minus Tf upon T0f minus Tf is equal to, this is for the Cg, that is cane sugar, and this is for the glucose, is equal to WCg upon mCg upon Wg upon mg. Okay, now put the values. T0f having value 273 minus Tf value 271 for the cane sugar upon T0 value again 273 minus Tf, because we are going to calculate the value of Tf for the second solution, is equal to WCg. WCg is 5 gram, that's why 5 divided by mCg having value 342 upon Wg, that is also having value 5. mg, molar mass of the glucose, is 180. 5 get cancel, and that's why we can subtract the value 273, subtract 271 from 273, and the value will be 2 upon 273 minus Tf is equal to, here 180 goes to the numerator and 342 towards the denominator, and that's why 2 upon 273 minus Tf is equal to 180 divided by 340, and that's why 273 minus Tf is equal to 273 minus Tf is equal to, wait a minute, 273 minus Tf is equal to 2 into 342 divided by 180 divided by 180. During calculation we will get the value 273 minus Tf is equal to 2 multiply by 342 or 2 divide to 180, that is it will become 342 divided by 90. 342 divided by 90. Here we can take the log calculation. Log of 342 is equal to 2 point and log of 90 is equal to 1 point. The log of 34 into 2, value for log of 34 into 2 will be 5340, and for the 90 characteristic is 1, log of 90 in 0, log of 90 in 0, that is 9542. Both the terms are in a division, that's why there should be subtraction. 8 here, 9, 7, 14 minus 9 is 5, and here 2 minus 2, that is 0, and go for the antilog. On antilog of this term, antilog of 0.57, antilog of 0.57 is 9, 3707 plus 7, that is 3714. 3.714, that will be the value. And that's why 273 minus TF is equal to 3.714. 3.714, and that's why TF is equal to, TF will goes towards the right hand side and this term will goes towards the left hand side. That's why TF can be written as TF is equal to 273 minus 3.714. On subtraction we will get the final value of TF, that is 6, here 8, here 1, and here when we will subtract the value from 272, that is 269, that is 269.18, 269.18 Kelvin. That will be the final calculation for the all the term. Here in your textbook the final value is 269.06. No doubt it is 06, because actually what we did here, we go for the calculation directly. Actually all these calculations should be using logarithm. When you will use the logarithm here also, then you will get the actual exact value. So don't take tension, that is not the issue, because when there is 0.06, the value greater than the 5, it will become 1, and that's why it can be considerable value, 269.186. This is our second problem. We will repeat once again. Here there are two solutions in this equation. First solution of cane sugar, that is 5%. Second solution of glucose having 5%. And that's why the masses of glucose and cane sugar, that is 5 gram. WCG means the mass of cane sugar. WG is the mass of sugar, that is glucose. And molar mass of the cane sugar is 342. Molar mass of the glucose is 180. Here TF value is 271 already given. Here TF value we are going to calculate. T0F value for both the solutions having same, because solvent is same, water, and water freezes at 0 degree Celsius, that is 273. Here also 273. That final value changes because actually 0 degree Celsius, uh, while converting into Kelvin, there is addition of 273.15. We have already taken round of, that is 273. Here also 273. That's why that error arises. Okay. Delta TF is equal to T0F minus TF. As we know, that is depression in freezing point according to the formula of the depression in freezing point. T0F minus TF, and delta TF is equal to KF into M. This relation also we got studied. M is the molality, and according to molality formula, W2 upon M2 upon into W1 into 10 raised to 3. For first solution for cane sugar, delta TF is equal to KF WCG upon MCG into W1 into 10 raised to 3. For second solution for glucose, same formula applied, that is second 1 by 2 for the operation 1 by 2. In this operation KF get cancelled, 10 raised to 3, 10 raised to 3, W1 get cancelled. Here WG and CG will get also cancelled because both are having 5 gram. Here also you can go for the cancellation. Now formula becomes delta TF means T0F minus TF, T0F minus TF, here T0F minus TF for CG, for G, WCG upon MCG upon WG upon MG. By putting the values 273 minus 271, 273 minus TF is equal to 5 upon 342, 5 upon 180. And on rearranging the term, we will get the value 2 upon 273 minus TF, 180 upon 342. And by calculating all this term, we will get the final value, that is TF is equal to 269.186 Kelvin, and that is the freezing point of the glucose solution, that is the second solution. This is about the third problem of your solution chapter. For today's video it is sufficient. Watch this video again and again and understand how to solve these problems. Okay, and try to solve the next problem. Otherwise in next video we will solve that problem also. So have a nice day. Thank you so much.